Lesson 99 is on using differentials for linear approximations, and I think you'll really kind of like this. Probably never thought about being able to use calculus for this. So on page 508 it says Lena and Jen have a solid brass ball whose radius is 20 centimeters. They want to know the change in volume when a 0.02 centimeter coating is applied. So that would be a difference in the radius. That would be 0.02. Estimate the change using differentials. Well, first of all, we're looking at the volume, the change in the volume. So the formula for the volume of a sphere is 4/3 pi r cubed. And we just take the differential equation of this, it would be the change of volume will be equal to 4 pi r squared dr. So the radius was 20 to begin with, that's r. The difference in the volume will be 4 pi times 20 squared times, now the difference in the radius is how much of the coating they're going to apply, so 0.02. So the difference in the volume would be 100.5310 square centimeters. And as you can see, if we actually plugged in 20.02 for the radius in the actual equation, we would get 100.6315, which is not very much different from this. So it's a pretty good approximation using the differential. Okay, on page 509, it says if X represents the number of units produced by a company in a given period, the profit P in dollars for the period is given by the equation P of X is equal to 500X minus X squared minus 1/2 X squared minus 72X plus 3,000. All right. Using differentials, estimate the change in profit when the production is increased from 115 to 120. So what we'll do is we'll begin with the 115, that's our original amount, and then the difference in X will be 120 minus 115, which will be 5. So we're going to start by taking the differential equation. So dP will be equal to 500 minus 2x minus x, and this will be plus 72, and then the derivative of 3,000 is 0. So that simplifies to minus 3x, oh, and this is dx, sorry, minus 3x plus 572 times dx, and now we know that dx is 5, so, and the original x was 115, so minus 3 times 115 plus 572, and then times 5. So that would be minus 45, 4 plus 572 times 5. Minus 5 is 7, 6 minus 4 is 2. So that comes out to be, times 10 is 35, 10, 13, 11, 35. Okay, so a difference of 11.35 in the profit. Now, if you look, if we go back and plug in 115 into this equation, that would be equal to $42,942.50. And then if we plug in 120, that's equal to $44,040. So that would give us a difference of P120 minus P of 115 equals $1,097.50. So as far as approximations go, that's not a bad approximation. $37.50 difference. So that's pretty good. Okay, one more. Also using differentials. It says use differentials to approximate the square root of 9.4. Well, we know that the square root of 9 is 3, right? So we could find, we can let the function be f of x equals the square root of x, which is 1/2, x to the 1/2. And our original x will be 9. And then our dx would be 0.4, because that's how far 9.4 is away from 9. So if we take the differential here, or call this y, then dy would be equal to 1/2 x to the minus 1/2 times dx. So then dy would be 1/2, let's see, that would be x to the 1/2 is the square root of x down here. We're going to plug in 9, and here we'll put in 0.4. So that would give us 0.06 with the 6 repeating. So then we already knew that the square root of 9 is 3. So then an approximation for the square root of 9.4 would be 3 plus this differential. So it would come out to be 3.06 repeating. All right.